Determine if the correlation coefficient could have arisen due to chance by constructing a hypothesis test with 0.05% significance. So we can set up our hypothesis. Where our null hypothesis has the correlation in the population is 0, and our alternative hypothesis has the correlation in the population not being 0. Now, anytime we do a hypothesis test, we typically will set our critical value using our t-value chart. So we have set our degrees of freedom is n minus 2, and in this example, it's a continuation of our last example where we had 5 observations, so we have degrees of freedom of 3. We have a 5% significance. Now this is two-tailed because it can be a less than 0 or it could be more than 0. So we have a two-tailed 5% significance with a degree of freedom of 3. And we get degree of freedom of 3.182, or a t-value. So our critical value is 3.182, or t equals 3.182. So when we do our hypothesis test, we can create we'll do our formula for t to get our test statistic, and if it is between 3.182 and negative 3.182, because this could be negative, then we can reject our hypothesis. But if it's higher or lower than those, then we will not reject it. We will not have enough evidence to reject it. So our testing correlation coefficient formula is t equals r n minus 2 divided by the square root of 1 minus r squared. So we get a t-value of 5.32. Because 5.32 is greater than 3.182, we reject our hypothesis. In other words, the correlation in the population is not 0, and there is a relationship. Sorry, we would reject our alternative. There is a correlation. As your sample size gets larger, strong correlations become more significant. The smaller the sample size, the more extreme the correlation needs to be for it to be relevant.